we've seen this. Is this all we need to know? Clarify. We've seen the 6 curves. Is this all we need to know? Let's read the question. Graph the curves. So graphing curves, I'm sure you're all good at it now. Okay. If they ask you to graph the curve of sec, make sure you put the graph of cos somewhere for yourself, and then you can be able to change it to the graph of sec. Okay. If they ask you to put the graph of cosec, you know cosec is 1 over sine, so do the graph of sine somewhere and then change it to the graph of y equal to cosec x. Okay, you understand? That is how you do it. Now look at the other thing. They said, okay, graph the curves. Okay, we're going to be able to do that. Now they said together with their equations of the tangent lines. Equation of the tangent line. Okay, so I can be able to do that. Number 1, I know that I'm doing an equation of a line. Because it's a tangent line, it's a tangent line. So I know it's an equation of a line. Now now remember that when I'm doing an equation of a line, I mean in high school we used to say that the equation of a line is y equal to mx plus c. That is the general form of the equation of a straight line. But we don't use this now. It's outdated. You know why? Because we don't like things that need us to know this. C, the y-intercept, we don't like that. There is something which is easier for us. So how are we going to do the equation of a line if we're not using that? Well, there's another one which comes from the formula of gradient. We know that the formula of gradient is change in y over change in x. And we can say that the formula of gradient would have been y minus y1 over x minus x1, right? Now, this is the one which we use because we just take x minus x1 to the other side and we'll be having m multiplying x minus x1 giving us y minus y1. And this is the one which we use. We just say y minus y1 is equal to m multiplying x minus x1. This is the one which we are going to use to find y minus y1 is m multiplying x minus x1. This is the one which we are going to use to find the equation of a line. This is the one we use now. Okay, so tangent, we're going to use this guy. What are the things that we need to know now? Instead of us having to know the point and this c and the gradient as well, we only need to know one thing, which is we only need to know 2 things rather, which is m. This is the grad, and we find it by doing differentiation. That's why we are doing this under the topic of differentiation, because they want to see if you know that if you differentiate, you find the gradient. So differentiation will give us m. Then there's going to be a point called x1 comma y1. This is the point which you're going to have your curve pass through. So you're going to go a certain point which your curve is passing through, and that point is the one you're going to put, because we don't want to see x1 and y1 in the equation. Okay, you understand that? Good. So we're going to substitute those 2. So what is the thing? Let's just I'm going to remove everything and say, what have I just said? I've just said that now for the equation of the line, or the equation of the tangent line, we're going to say y minus y1 is going to be equal to m multiplying x minus x1. For us to be able to use this, we need to know the point which we are passing through. A point, not just the x coordinate, but the point which you are passing through. So we need to know the point which you are passing through. Then we need to know the derivative at that point. Okay, that's the m. M is the derivative at that point. So it's that you first differentiate to get the derivative function. Remember that differentiation gives you the derivative function. In other words, the formula for derivative. Then you put where you are. You'll be saying you are at position x equal to something. You put that in the derivative and you find m. M is the derivative value. It's a value. This is a value. It is a value. And remember, it is your derivative. Okay, your gradient. Gradient is the derivative at a point. Okay, so we're going to do differentiation to find m. Then we have this x1, y1, and we'll be able to put in this, and we'll be able to find the equation of a line. Look how easy this is. This has to be amazing. Come on. I know it is amazing. Now, let's solve it and let's see how far we can go. Okay? Goodbye for now. We're going to go and do it in the next question, in the next video. Bye.